A subject of great debate, especially between creationists and evolutionists, is the age of the sun and how it all came to be. It has been accepted by some that over billions of years, dust left over after the alleged Big Bang slowly coalesced together and eventually collapsed in on itself to form our sun. Sometime afterwards, the remaining material slowly spun itself into our solar system. Technology today is advancing so that we can collect more data about the universe, and at every turn, the evidence that has been collected does not show that evolutionary theory is valid, but instead shows the sun to be of a much younger age.
Most astronomers think that the Earth, the Sun, and the rest of the solar system formed about 4.5 billion years ago. Their basic idea was that the whole thing, the solar system, formed from a large gas cloud. This large cloud was perhaps a couple of light years across, and it slowly contracted under its own gravity. How it got started, well, that's kind of a miracle. They don't know. But once it went so far, then gravity took over. And as it did, most of the material fell to the center to form the proto-sun. And the rest of the material flattened down to form a disk. And out of this disk, the planets would form, supposedly. And they didn't happen all at once, though. Little tiny particles began to coalesce, and as they coalesced, they grew a little bigger and a little bigger, and then eventually you got bigger chunks that had enough gravity. We're not talking, 100 miles across or something. Started attracting other particles to them. But that's, if you get so far in the process, you have really big objects, you can actually absorb gravitationally. But getting started is the problem. They have to get these little tiny microscopic particles to stick together to form bigger particles we call planetesimals, from which the planets supposedly formed.
Although there is no known physical way to get these particles to coalesce, this theory is widely accepted among the scientific community as fact. Physics tells us that these particles will not stick together due to their own gravitational attraction to one another, nor will gas contract without some sort of outside influence.
There's no real way to get them to stick. There have been some simulation attempts, some experimental attempts, and as of yet, no one's been able to come up with a mechanism whereby the process gets started. So you have another miracle, a miracle to start the process of contraction of the gas cloud, and another miracle to get the planets forming inside that disk. So you've got at least two problems to solve right there. And this is a very gradual process. If you ever did get it going, it'd still take millions of years for this to happen. And since in the creation model, we believe the creation was done in 6 days, only a few thousand years ago, that doesn't work very well for us. So we have a number of scientific objections to the theory. We also have some biblical objections to it.
Some scientists have seen the problems with spontaneous gas contraction and star formation and have sought other ways to explain how it is that our sun formed. There needed to be a mechanism found that explained how this contraction could occur, since it could not have possibly occurred without some outside influence. It needed to be a very large and energetic means to push these giant dust clouds together to cause a contraction strong enough to force the hydrogen together to begin the process of fusion, and thereby creating a star. Physics again tells us that as a gas cloud in space contracts together, it will only contract to a certain point. After that, it will expand again. They believe they found their answer in supernova. Supernovae are very rare and violent exploding stars that have throughout history rivaled even the brightest stars in the sky in brilliance.
A few years ago, the Hubble Space Telescope sent back some startling pictures in a region or edge region of a thing we call the Eagle Nebula, and these big ghostly spires that they called the pillars of creation. And they thought up at the tips of these things, the density of the gas was such that gas clouds were contracting down to form stars. And indeed, in some of these regions, they could identify some very bright stars amongst it that they said were newly formed stars. And most people walked away thinking, wow, we've proved star formation. Well, have we? You've got these bright stars here in a place that people allege would be the region of star formation. But did we see the stars form? Well, no, they're there. They formed already. How long ago, we don't know. It could have been, quote unquote, recently in an evolutionary model, or it could have been long before that, or even more recent than that. We don't know. The process of star formation allegedly takes place so slowly that it would take many lifetimes to see any change. So we've never actually seen a star born. And there are some problems with the idea. A gas cloud is this big thing. It's really cool. And if you contract it down, it gets a lot smaller. It gets hotter, it gets denser, and it gets to be more and more and more like a star. If you really examine it, the big difference between a gas cloud and a star is merely size. If you can get the large thing down to a small thing, everything else presumably would change. So many astronomers assume, well, that's what happened. The problem is, how do you get it from being real big to real small? If the cloud has a certain size, a certain maximum size, then the cloud will contract under its own gravity. It will come on down to make a star. The problem is, all the gas clouds we see are far bigger than that, quite a bit bigger, not even close. So the gas cloud's like this, and it has to be like that. And how do you get it from this down to that? You see, if you start to contract it a little bit, the gas pressure increases and pushes it back out. We say in the physics that it's stable against collapse. So the big trick is to get that gas cloud down here with some sort of jump start. And to do that, you need some sort of compression to come down and squeeze it. And there have been several processes that have been suggested. One of them is that a bright supernova goes off nearby, a big explosion, and the big shock wave, the stuff comes out, the gas comes out a couple thousand kilometers per second, slams into this gas cloud, and before the middle and the back of the cloud know what's going on, this side's being shocked and compressed and pushed in like this. And so they hope that this could perhaps trigger the collapse of gas clouds. And as a scientist, I look at this and I think, well, that might work. That might work. What it requires is a gas cloud to be fairly close, but not real close, to a supernova. Well, the only problem is what is a supernova? Well, a supernova is the explosion of a massive star. Okay, well, where'd that star come from that just exploded? Well, there was another supernova that blew up next to a gas cloud and compressed that gas cloud to form this new star. But where'd that supernova come from? And you see, you keep going back and back, and you see that you need a supernova to make a star, to make a supernova to make a star, to make a supernova to make a star. And ultimately, this mechanism, while it may tell you how stars form today, it won't tell you where stars came from originally. You need some other mechanism.
Seeing the